Okay, we started section 2.3 last time, and we're just going to fly through a little bit of this just to remind ourselves of where we were because it's been a weekend. We talked about some set operations in this particular section. In particular, there were 3 or 4 that we talked about. The first one we talked about is set intersection. And intersection simply means what the two sets have in common, where they cross, where they meet. We talked about the street intersection of, in the intersection of two streets. The second we talked about was the union. A union is a collection where we just combine everything all together. So it's a sort of combining operation. And we talked about a marriage ceremony. So you get my kids, I get your kids. You get my money, you get my debt, that kind of stuff. It's all combined. It all becomes one. Okay, so that's the idea of a union. And then we also talked about relative difference. Relative difference is the idea of taking some collection and then removing a portion of it. So you get this sort of half-moon shape on the left-hand side of A. So it's everything in A, but we sort of exclude a little piece of it some way. There's some examples with that. Mentioned this idea about commutativity, associativity, and distribution. Basically, all the things that you have seen versions of this maybe with a little bit of algebra, they look very similar with our set properties. There's a cardinal number formula that's quite helpful when we're doing counting arguments, which we're going to be doing today. So when you're talking about taking the number of items in the union, you can count the number of items in each set individually and then remove the double counting by removing the amount that was in the intersection because it got counted twice. And then Cartesian product was the other example that was in there. With the Cartesian product, what you're doing is you're sort of grouping things together in ordered pairs. So you're making a grouping from one set to another set, and you're kind of combining them together. And you're doing that in every possible way that you could put those ordered pairs together. All right, so we had done some Venn diagrams last time, and the Venn diagram that is most related to what we're going to do next today is this last one right here that we did. In this particular example, you were given the number of items and a lot of different combinations of things. Most of them were intersections of different things. So 2 things intersecting or 3 things intersecting or just maybe one item all entirely in itself. And then what we did is we looked at how to sort of piece that together. And in this one, we sort of worked at what is the most restrictive piece of information I have. And on this one, it was the piece in the very center. It doesn't always happen. It doesn't always work that way. But it can. So it started with something in the very center, most restrictive, and they worked its way out. Let me make one other comment just thinking about your homework. When we were working on these examples right here, we created Venn diagrams where we had 3 overlapping circles. So we ended up with 8 regions, right? When you're doing your homework, some of the time they're going to give you images that don't look like 3 overlapping circles, which is totally fine. And so you end up with your numbering different. For example, they might actually give you a diagram that looks like, 2 circles overlapping, but one of them is not. That's fine. You just put your numbers in whatever does overlap. Okay, so there's nothing special about the way that these 3 overlap. That's the most general way it could happen. But if you had something like this diagram going on in here, and you said, okay, this is number 1, and then I've got 2, 3, 4, and here's number 5 on the outside. And then everything else works the same way. There's nothing special about this particular picture versus the other one. You just have fewer overlaps to look at. Okay, so they create these pictures for you on a couple of your examples. I just want you to be aware of that. Okay, let's take a look at an actual application problem of Venn diagrams. Joe Long works on albums for musicians. Last year he worked on 12 projects. He wrote and produced 2, he wrote a total of 5, and he produced a total of 7. We're going to answer some questions specifically about how many he wrote, produced, those sorts of things. But the way that we can most easily answer those questions, and what I'm expecting and basically what the book is leading you to in this section, is that a Venn diagram can be very helpful to make these arguments make sense. So we're going to actually draw a Venn diagram based on this information. All right, so take your pencil or whatever and make yourself a rectangle. And the first thing you have to do is you have to figure out what in the world are the categories inside of this rectangle and how many of them do I have. So what is going on inside of my rectangle that I've drawn?
How many projects he wrote?
You've got 2 circles. One of them is going to be how many there he wrote, and what's the other one going to be? How many he produced. And we're going to draw them in the most possible, the most complicated way possible, which is that they overlap. That's the most complicated picture that we could have happening. Do they have to overlap with the information given? They wouldn't have to. These actually do, but they wouldn't have to. So in your diagram, you're going to label them. You're going to label one of them wrote and one of them produced. And you can call the outside set just universal set U. Okay? It's all the article or the albums. There we go. All the albums that we're referencing here. Okay, they give you they give you 4 numbers, I think, actually. They tell you that he worked on 12 projects. They tell you that he wrote and produced 2. They tell you he wrote 5. And they tell you he produced 7. Okay, so what piece of that information is the most helpful piece on this particular one to start with? The wrote and produced. And how many did he write and produce? 2. Where's that 2 going to go? In the very middle and then overlap. So we're going to start by putting a 2 right here. Okay, so let's go back now and read a little bit more. We've sort of addressed the first issue, wrote and produced 2. We've got that one done. We've got 3 others. We've got he worked on 12, he wrote a total of 5, and he produced a total of 7. Which piece of information might be most helpful to do next? The 12, the 5, or the 7?
Either one, right?
Either the what?
You can do either one. Either the total wrote or total produced. Don't you want to put those numbers?
Right, but we're not going to do the 12, right? The 12 is unhelpful still, but either the 5 or the 7. You're exactly right. So we have choices. We can either pick the 5 next to work with or the 7 next to work with. I'm just going to do the 5 because it's listed first. So it says he wrote a total of 5. So that means up here in this circle that's wrote, this whole circle combined has to be a total of 5. But there's already 2 there. So I'm not going to write the number 5 down. What number am I going to actually write down?
3.
A 3, you're right. So we're going to put a 3 right here. Okay, and we have now taken care of the wrote a total of 5. All right, the next one is going to be that produced a total of 7. So again, that whole circle for produced has to be combined 7. But there's already 2 there. So how many more do I need? 5. The most common mistake students make when they do these Venn diagrams is they forget to not count the piece that's already there. And they'll end up putting the 5 and the 7 just straight in the diagram as is. And then they get really confused because they end up with more than 12 numbers in their diagram. It adds up to too many. Okay, so right now, how many total do I have in my diagram? 10. And how many am I supposed to have? 12. So how many do I still have to put in somewhere? 2. And there's only one place left to put them. It's where? Outside the circles. So somewhere outside here, you're going to put the number 2. And once the diagram is complete, the answering of the questions is usually very, very easy because your diagram just shows you what the answers are. There's no reasoning things out really to speak of because you already did it. All right, so the first question says, how many projects did he write but not produce? 3, that's correct. Very good. That's my outer circle, the circle that says wrote. How many projects did he produce but not write? That's the outer part of the produced circle, 5. And how many projects did he neither write nor produce? That one is the outside of all the circles, but inside my rectangle too. Sound good? Okay, we've got one more. A youth group was asked questions regarding songs they had learned as children. Upon surveying the 34 youth, the following were obtained. 15 had learned Jesus Love Me. 19 had learned the B-I-B-L-E. 28 had learned This Little Light of Mine. 13 had learned Jesus Loves Me and This Little Light of Mine. 15 had learned Jesus Loves Me and the B-I-B-L-E. 14 had learned both the B-I-B-L-E and This Little Light of Mine. And 13 had learned all 3. All right, so we're going to create a Venn diagram, and I'm going to have to do it on another slide because there's absolutely no space on that one. How many circles are going to be inside of my Venn diagram? There are going to be 3. How do you know? There were 3 songs that it referenced, right? And I need circles for all of them. Okay. And we're going to label them. I mean, if you want to give them number or like letter names like A, B, C, and then go back and tell me A is This Little Light of Mine and that kind of stuff, that's fine. But you can also just label them with an abbreviation of what it's referencing. For example, the first song that it's listed is what? Jesus loves me. So I'm going to just label the first circle as Jesus, okay? The second song listed was the B-I-B-L-E, so I'm going to just label that B-I-B-L-E. And the third song listed was this little light of mine, so I'm just going to write down light. That's clear enough what we're referencing to work with. Now, you've got all those pieces of information on your paper, and I do as well. Which piece is the most helpful piece to start with? The last one. Because it's the most restrictive, right? It gives us the most pieces of information. It says 13 had learned all three. What does that mean I need to do? 13 in the middle. And if you're thinking sort of back on your list, and what I would do if I was working this with you on the same sheet of paper is I just marked a line through it. We already did that one. We don't have to think about that again. All right, these three now that are at the end and these three that are at the beginning are distinctly different. The three at the beginning all talk about one individual song, and the three that are in the sort of sandwiched in the middle all talk about two songs combined in some way. Which set of those do I want to use next? The two song comparisons, right? So my second set right here is the pieces of information that's most helpful. And it doesn't matter whether I start with the 13 of those three, or if I start down at the 14, or if I start in the middle for the 15, it doesn't really matter. So let's just work from the bottom up. Is that okay with you? So it says 14 had learned the B-I-B-L-E and this little light of mine. So if I take a look at my diagram, the B-I-B-L-E and this little light of mine is this particular region right here. And there's already 13 in it, which means how many are missing? Just one. So there's going to be a 1 that goes right here. All right, and we're going to draw ourselves a little line through that one. We took care of the 14 about B-I-B-L-E and this light of mine. Going up from there, I have 15 that learned Jesus loves me and the B-I-B-L-E. Okay, so Jesus loves me and the B-I-B-L-E would be this overlap right here. And there's supposed to be 15 in it. I already have 13 accounted for in the middle. What's left? 2. So I'm going to have 2 right here. Okay, the last one that it gave me information about is that last overlap, actually. So I have 13 had learned Jesus loves me and this little light of mine. So we will go over here. Jesus loves me and this little light of mine would be this overlap. I already have 13 in it, and there's supposed to be a total of 13, which means what number goes in this blank out here? 0. So could the diagram have been drawn differently? Yeah, it could have, because there's really nothing in that piece. But it doesn't hurt to write a number 0 in it either. It works just fine to put a 0 in a spot. Okay. All right, we're working our way through all this. We've got all of those second set of ones done. All in the first set, doesn't matter where we start. I'm just going to start at the bottom, 28. 28 had learned this little light of mine. So over here on my picture, this little light of mine is this entire circle. How many are in it so far? 14. How many are there supposed to be? 28. So how many are missing? 14. Just a subtraction problem, right? So we've got those 14, and that took care of the 28 piece of information. 19 had learned the B-I-B-L-E. All right, so the B-I-B-L-E is this circle right here. I've got 2, 13, and 1. What's that a total of? 16. And how many is it supposed to be? 19. So how many are missing? 3. So we'll have 3 on the outside here. That piece is done. The last piece of information in sort of my bulleted list, if you will, is that 15 had learned Jesus loves me. So back in my picture, Jesus loves me is my last circle right here. I have a 13 and I have a 2. That's a total of 15. How many am I supposed to have total? 15. So what's going to go on the outside part of the Jesus circle? 0. Okay. Wonderful. Okay. Am I done? I'm really close. There's one more piece of information that I haven't used. The 34. This says 34 youth were surveyed. So they all had an answer and fell in one of these categories, and there should be 34 people's opinions represented here. The question is, how many are actually represented? Are there 33? All right, so I'm missing 1, right? That would mean I'm missing 1. If there are 34 and I've got 33 listed, I'm missing 1. Does that look right? Everybody good with that? All right. Let's answer our questions now because our diagram is finished. How many children had learned exactly one of these songs? So where in this diagram is that referencing? What is exactly one looking like in this diagram?
Like in the big circles, but not in the overlap.
Okay, so like this piece, and this piece. Those are the people who knew exactly one of the 3 songs. What are the numbers that correspond to those shaded pieces? 14, 3, and technically the 0, right? But of course that doesn't give us any value. So over here, it's going to be most helpful for you and for me if you actually will write out what you're adding together. There's a 13, there's a 4, and there's a 0, and this is the work I would expect to see to show where in the world you got 17 from. Okay, because that's what we would have on there. What does at least 2 of these songs look like? Okay, this piece would be 2 songs, this piece would be 2 songs, and this piece would be 2 songs. And I also get to shade in the 13. Why? Because it said at least. So what does at least 2 mean? 2 or more. It does. So I have to include the 13 in the middle. So I've got 0, 1, 13, and 2. And what is 0 plus 1 plus 13 plus 2? 16. None of these songs, 1, that's that little lonely person on the outside of the circle that we put in as our very last number. And then the last question it said, is this little light of mine only? That's 14. Any questions on that?